I'm Goudreau from Arcbees. We mostly okay. So we mostly build this business around Good Platform, but I'm not here today to talk about Good Platform. I will be talking about how to efficiently write code generator. And aside of the tool that I'll be using there, I want you to take a close look at the patterns that is used to separate the logic and from the presentation itself. So you can drive it. Once upon a time, that's mostly what I say to my son when I take him to bed. I hope that no one here will be sleeping after I'm talking. But when we first write Good Platform, Philippe Baudin was the one that wrote the code generator at first. And over the year, I took over the role of maintaining most of the code. And the code generator was one of the most complicated part of the framework. And the first time I got into the code, I scratched my head literally. I wanted to, I didn't understand at first. Well, at first I'm talking about the 21st minutes where you try to find out where you should start to look at, and then you have this class that is mostly 1,000 line of code. And that got shrinked a lot through the version of GWT, but still is a little bit hard to understand, to maintain, and to expand through new functionality into the evolution of the product. So one of the main things that I'm working at Arcbees when I'm working on project is about simplicity. And every time that I'm looking at that kind of code, I'm always wondering how can I make it simpler so that I can have an easier time when I'm looking at it years afterward to be able to make some change and to make sure that I can evolve the project accordingly. So I took this little Leonardo da Vinci phrase about simplicity is the ultimate sophistication, and that really shows how we work at the Arcbees as well. So, is it too complex? Well, for the person that wrote the code, it's not, because he is the one that got involved in the project. He's the one that has to think about everything that is in the project. And although it seems simple for us to maintain that piece of code, that doesn't mean that we will be the only one to maintain that piece of code. It can be, and while you're at it, even right now, while working on Good Platform, it's not even me that is working most on the code base right now. It's other people from around the world, or even Johannes right here as well, or the people inside the business that is taking care of maintaining the project. So is it too complex? Maybe not, but we want to be friendly for the other one that will take over the code over the year. So I have a small graph that I want to show you. You doing that? Yeah. About complexity and the time it takes for a developer to be able to truly get the project. So you have the time it takes to get how the project works and the complexity of the project itself. So I'm okay.
It is mirrored. Okay.
Okay. This is not based on scientific facts or anything. It's just based from my experience with other developers and with projects where the simpler it is, the faster you get. But it doesn't mean because it's as simple as possible that it's complex enough. So you have to find the right the right measure, the right balance between complexity and simplicity. And I think it's just in the middle, where you have this little place here where it kind of balances itself before going really exponential, where you just adding something becomes a real challenge because it's too complex. So if we go to the next slide, but you don't have to show it right now. Oh. The next slide is kind of the same thing, but this one is more for the businessman in the room. It's about complexity and money. So you kind of have the same the same graph here, because the more complex is your software, the more money you will have to inject in it to be able to maintain it. So that's that again. If you're building something that will where you will spend years maintaining it, making it evolve, and that you don't want to start again from scratch because it's becoming too complex, you have to find the right balance between complexity and simplicity. And this is not something that everyone here, I'm sure, knows about that. And this is not something new. This is something that has been around for years. But this is something that we tend to forget when we try to be on time for a release. That we try to be that we try to be on cash on budget as well, because sometimes it's easier to just do the feature really fast and not think about how you write it and how you maintain it and deliver it at the end of the sprint. But in the end, it will always come back and bite you because you are growing a technical debt. So let's go back to the slides. This is funny. I thought it was working. So, too complex. It depends on who's behind the wheel when you write the code. Well, and I showed you the small representation of the cost and the time it gets before you understand something. So, while I was working into GWT to make this new feature on generating the Ginge Actor, if does anyone here is familiar with Google Ginge? Actually, probably most of you. There's a feature that is really nice that I found in CDI, which is to be able to get a class that actually you're able to do with Juice, but not with Ginge from the Ginge Actor. And how you the only way that you can get a class in Ginge is to add a getter or it into the Ginge Actor itself. So
You filled in the past, you have multiplied.
Yeah. So, but in GWT, we were using getters for each presenters, and everyone that was that needed to bind their presenter with their views and things like that needed to have a getter to the presenter inside the Ginge Actor. The reason was simple. It's mostly because the provider for asynchronous when you guys created the async providers into Ginge. No, that's not what I meant. But the code splitting feature. So when the code splitting feature appeared, we introduced an async provider and end provider into GWT, and that made us create a code generator for our proxy class to the presenter, so that the code split was behind, was done correctly, since most of the class were injected right into the presenter. And if we didn't introduce a proxy, they will get mingled together and got into the same split point, behind the same split point. So we introduced a proxy interface to the presenters that are known at runtime, but not the presenters. And that introduced the need for people to add a getter into the Ginge Actor for every single presenter that they had, with either provider or async provider in it. So when I started to work on this, and I wanted to remove this need for each presenter into the Ginge Actor, so I created a Ginge Actor generator that was looking up. And this is something that is going to disappear, I think, but I will have to find another solution, which is looking basically on the class path for every proxies that was declared by the user. And I was generating the Ginge Actor itself from the definition of the proxies that was there. And then, so while I was creating that, I was wondering how I can simplify my life so that the next time I work in it, I don't have this problem again, like having a hard time to understand everything behind it. And since I don't like to spend hours to read some code and to understand what's behind, well, I was thinking a template engine would be really great, actually, to separate the presentation logic from the business logic of creating those classes. So at first, I was going to build my own, but then, well, we were already using velocity templates for emails and things like that, and other kind of usage, and I thought, well, that could be a great idea. So I started for this session, I will start with a simple use case, which is already in our Carster sample that we're delivering to developers that use GWT platform. Simple table, 4 columns, ID, car, rating, delete. This is a common pattern that every developer that uses GWT is doing every day, defining columns into cell tables. And it's kind of always the same code that you have to write. So, like, take a look at the code. Really classic column definitions. There's not a lot of stuff. It's still too small. Let's zoom this a little.
Control plus. That's fine.
Yeah. Is this a little bit better?
Mm-hmm.
So classic column definition. But it's still too long. If you have 9 columns, 10 columns, or if you have to change it, you have to rewrite always the same thing. What if I could write this thing into 1 or 2 lines top for every column instead of having to always do that? There's a lot of code to write. Yeah, I need to get some more some of those code out. So the first thing I did is to extract the creation logic of every column into its own class through a column initializer. So you give it the table, and it creates a column for that table. Actually, this is something that I think that Julian has initiated into other project that I took away from him. But So basically, each column is created through a column initializer through always the same pattern of if I want to add a new column, I create a new method. And this is actually code that is really easy afterward to generate through a good generator. So first step, you write a real case, a real use case, and then you abstract it as much as possible. You try to define a common pattern that is easily repeatable, which is kind of counterintuitive when you're a developer because you don't want to repeat yourself. But in the case of code generator, you need to repeat yourself. You need to write code that is always the same, but only small pieces change out of it. And this is the key to write an efficient code generator, that it doesn't, that is not bloated with functionalities that you don't need. So coming back to my presentation, cleanup complete. What I preserve and what I thrown away. So if I would go back to my view, actually, the view itself would have a lot less responsibility than it had at first, since I extracted the creation logic from the columns into its own definition, into its own class. If I could go further, even further, by abstracting the cell table itself into its own class and having a two-line initialization for the table into the view. So the view is completely agnostic of how the cell table is actually created instead. So that makes a lot of classes, but that the cell table itself afterward, if you're using if you're in a big application, cell table tends to always have the same set of features. So it's a good thing actually to just abstract it into its own class for your application, so that you don't have to repeat to continuously redefine the table itself through the application. So the next step is actually creating an interface that will be used by the code generator to be able to generate the code that we need to recreate the class that we just saw before. So let's say I have something that looks like this instead. Oh. Okay. So all the code that we saw, if I go back to the column initiator, okay, that was the code. Say 41 line. Okay, maybe I could remove all the private methods and include that right into initialize column, but it will still be the same. More than 30 lines to define each columns and this is only 3 columns. So around 10 line of code for each columns. And now, well, I have 2 lines of code by columns. So I created 2 annotation, columns definition, which is which I passed the DTO that is given to the table. I created a notation called column, which I given the cell type, the return type of the cell, and the header name. And that pretty much it. The only requirement for this, it's like I kind of use the request factory model where you have a mapping that is one-to-one from the getter, the name of the method and the name of what is actually into the DTO. The toString is kind of strange right now because, well, it's kind of a hack because in retain DTO, you have an overload of toString that is returning exactly what I need into that column. So that's why it's really a mapping, a one-to-one mapping from the name of the method to the name of the method that is in into the DTO. Yeah, well, I think we're just starting to get to the point, what is behind the code generator and how we can improve the readability, the maintainability of those code generators by writing templates, actually. So what I have here is velocity templates. So I created some macros to override. The first one, the init, is exactly, the init column is exactly the same thing as each init ID column here. I don't, okay, now it's changed. There's a little lag.
Yes.
So it's exactly as this. Actually, I created a velocity template right from this code and used it as my container for my velocity template. So I have the column, each private each method, and then into the initialize method I have the calls for them. And then there's another requirement when you're using that kind of code generation, which is to re-implement each method that you're defining into your interface, even though you're not using it. So this is only recreating each method that the interface is creating, so that it doesn't complain about your type not being the same as the previous one. And then the template that is using all those macros to write exactly the same thing as we had here. And then how did I set up this velocity macro, velocity generator? I used first Juice, which is really awesome in those contexts because I really like that my class always have only one responsibility when I create them. And Juice, or any dependency injection framework, lets you really isolate the responsibility of your class and really helps you define the collaborators afterward. And that's what I did. The setup is really simple in itself. So you first have, I don't think I have the code for it into my presentation, but you first have to inject this this velocity column initializer generator into an entry point generator, which is bound through the normal GWT XML file. And then what I did is just define a column initialization definitions, which is getting all the types that I need into my template. I just put it into the template as a single object where I get all the information that I need to write the template. And then I generate the class with the velocity template. And I think this is as small as a generator could be, unless you have any other suggestion to make it even smaller. So in short, what's important into this presentation is not velocity, it's not Juice, it's not how I wrote my classes or anything. It's really about asking ourselves how we can make the code as simple as possible for other people to be able to read it, to understand it, to maintain it, and to extend it more easily. And I think that one of the first things that you have to do to be able to achieve that is to separate the presentation logic from the business logic of your generation. And turns out that we do that every day when we're building application, because UI binder is is exactly what it does, but for HTML and normal business logic. So why aren't we doing it for generators and things like that? And that's almost the end. I couldn't stop this presentation before asking a question to everyone. Is there anyone here that uses Google App Engine? Okay. When you're doing local development, what is the most painful experience when you have to look into the data store? The local data store.
I have any admin console? Or actually they added it. Did they add a local version of that now?
Yeah,
An admin console of,
Yeah, where you can dump the entity and browse each data store.
well, there's a data store explorer into Google App Engine, but you cannot change the values. Indexable, unindexed fields are not there, and you actually have to scroll. In the local data store, you actually have to scroll way onto the right when you have big entities. And
it could be improved. It could be improved, yes.
Yeah, it could be improved. So, well, we find that a little bit annoying, so we built a project that is called Google App Engine Studio, which lets you do that into a way that is more accessible to the user. It lets you modify, create, delete entity on the fly, and it even lets you profile what's happening. But that's already something that is into some of the API of Google App Engine, right? But that we improved that even to one step further. But that's another story. So if you're interested of seeing what it is, I don't have anything right now because I want to let you ask questions about the generator instead. But I just wanted to see if this is something that could be interesting to Google App Engine developers, because to me, when I'm developing an application and I can't change the values locally without entering some code into a class, or dropping everything that is in the data store and recreating again all the values, it seems kind of a waste of time to me. But if I could just change one of the values I want to test into an admin console for the local data store, that will help me really be more efficient while I'm developing, right? Does that make sense? Yeah. But I'm not. Okay. Anyone ask questions?
I guess no questions?
Yeah.
I didn't really get how it's related to the Google Web Toolkit generator. So when do your velocity template be run? So when do you generate code?
It's generated really through the GWT generator. So you have to specify the into your GWT.xml the generator when the type is column initializer, for example, generate with this classes, this generator. So the generator itself is a GWT generator.
So it's in compile time. So when so you won't really have these classes. Is it not a problem to debug these classes that you don't have in your workspace, or?
And that's why I like to have a class that is working before working on a GWT generator. Well, yeah, you can add gen and you. And IntelliJ would jump in those classes when you're debugging, but it's not as efficient as if you have the classes. I agree. But that's the trade-off between code generation and not code generation. Do you want to be actually able to debug the class itself? Do you want to hide some logic because it's so redundant that you wish that you could just throw it away or just not have to look into it, like column definitions?
Yeah, I wonder if you could use something like annotation processing, which is the new one, I guess.
Yeah.
That's kind of an ironic way of calling it because it's not. It sucks sometimes. But You know, because it would run outside of the quick compile, but then you could see the output. Not that the developer necessarily needs to see the output, or the IDE needs to see the output in this case. 'Cause
Yeah.
you're probably using a GWT create to get it or something like this.
Yeah.
Well, one option we've discussed if annotation processing doesn't work is potentially, like right now, we'll talk about this tomorrow. Right now, the compiler works in 3 phases. There's the precompile, there's the optimization phase, and then there's the linking phase.
Yeah.
And the generators actually run during the precompile phase. At the same time, it's parsing Java off the disk. It's kind of like running a loop. What we could look at doing is maybe moving out the generation phase to like a standalone command line utility, so that from your Anvil or Maven or whatever, you could say, run the GWT generators, but don't do anything else. Don't optimize. Don't do anything. Just generate the output code and put it in a jar file.
It's really interesting because
Then the next stage of the compiler is the jar file to feed into it. This is another source dependency.
Yeah.
But then generators would be disabled in that one.
But
The
what
trick-
if?
The tricky thing is that when generators generate code that other generators.
That's what I was going to ask.
Yeah.
Because I'm doing this on some projects where I generate presenters from some annotations, and then GWT takes out these generators to generate the proxies.
So this gets into like what I was talking about the fact that generators are assumed to see the entire world, and what we really need to do is get in the habit of specifying to the compiler your real build dependencies, right, and not just assume the whole world. So you could make that situation work, but you'd have to actually declare the dependencies up front. So for example, if you have module A, which generates code, and module B, which generates code based off of module A's generated code, then they would be 2 separate build dependencies, and there would basically be an invocation of the generator API twice, where the second one will be configured with the first one as a source input. That way, the source input to the second loop of the generator is scoped down to just the set of types that it would really need to access, not anything in the entire world, right? And so they're basically, in general, I mean, even in Google, we're starting to do this recently. We have this notion of strict dependencies, where we've gotten out of hand internally in our own repository, where people just lazily add dependencies to everything, and they don't scope it down to just what they need.
Yeah.
And it hurts the build time. It hurts a lot of different things. So getting people in the habit of basically, it's annoying, but actually specifying precisely the things that they think they will need.
If you actually bind somehow every single dependency that you need, you don't have to explore the class path to know where they are.
It increases the startup curve, so you just can't leap in, write a generator, and just have it go, find me all types of this, and then foo, you have to go modify your build file and make sure that all the types that you care about that implement foo are actually, prepared as dependencies for the generation stage. But that's one possible idea we've discussed for sort of scoping down generators. Again, though, it would break backwards compatibility. So, there would be some generators that would still have to run in the old system, and then there would be another set that would be like the ones where you actually have to take care into how
But it would break compatibility because the old ones just not be ported over? Or
Well,
just
GWT RPC at its core is all about figuring out all the possible types you might want to transmit, and if you don't let it see the whole world, you break that completely. So I think we talked about doing incremental compile before, and the best we came up with was, okay, we leave the existing generator API, and if you have any generators in the system that use that, you fall back to the old way, and then you print a warning, and then people can figure out, oh, if I can avoid that, then I can get these other benefits.
There's a lot of other stuff there too. I mean, UI binder, CSS resource, that safe HTML templates even has to look at code that it doesn't know. It's explicitly.
Yeah, but those are, I mean, you can tweak that without changing the basic philosophy of it. RPC is the one that you break the whole thing if you change the approach.
Well, editors, I mean, for the same reason, editors and UI binder are going to do that too, because they have to be able to see everything. Because they're going to be told when you start declaring those interfaces, just like RPC, what other types it's going to have to inspect and build up the types for. You can't build editor context.
Yep.
Right, but you don't have to find all possible subtypes of those types.
Yeah, the way
You can't follow the dependencies. With RPC, you cannot follow the dependencies.
Right.
Yeah, especially because some of the dependencies are on the server side, right? And you don't actually see if they're instantiated or not. And so, for example, if you have an interface that returns Java-lang objects, like if you return a list and you don't say what's in the list, the compiler goes, well, you're returning a list of objects, right? The server could potentially instantiate and put into that list any possible type that's on the class path. Therefore, the compiler will generate, or Goudreau will generate these serializers for every subtype of object that implements serializable. And so that could be a lot.
It's also the difference between the CDI and the Ginge follows just dependencies through the Ginge Actor interface. So if it only generates code for the types reachable from there. In the CDI case, it's in order to get all implementations of the interface, you need to ask system to return all possible subtypes for that interface. So that means you need to know all of the system. You cannot just work one part of the application. You need to run after everything compiles and every type is available so that you can see all the types.
So this code generation stuff you're talking about, seems like Java in general, a lot of people want to try and do metaprogramming with something like APT, and it has its warts and whatnot. Yeah, something. I mean, it almost sounds like that would not necessarily have to be GWT specific. Potentially,
Not
it's
necessarily.
just a
I mean,
code generator.
if you look
right?
at, like, for example, look at Dagger, which is what Square is working on, right? They're basically moving away from over-reliance on magic.
Yeah.
And more on basically, like, you have a tool that basically produces source that basically gets compiled at compile time. And so, obviously Dagger is less magical than Juice is because of that, because it doesn't do AOP style injection, at runtime. And so, it might be the case that if we design a future generator API, it could be more along the lines of like a Dagger type thing, where basically it can run statically as a pre-built step, and it wouldn't actually be GWT specific. It can just work for any type of code generation scenario, because as far as it's concerned, it just produces regular Java output.
The one issue with taking generators and running them totally standalone from the GWT compile is now you've got to worry about dependencies between the generators. I'm not sure how you express that without just making a lot of burden on developers.
Yeah. I mean, some of this also it might actually kind of relate to your talk later, which is like to even be able to do that, also you have to kind of solve the problem of constructing a type oracle, without basically doing a compile, right? And so like if you want to do server-side ITN, it would be nice actually if you just had, if you're doing server-side generators, if you just had like a type oracle handed to you, didn't require running the whole compiler, right?
Yeah.
And so it's
that
sort of
type
the same
oracle is a
problem.
mixed bag. In such terms, it's awesome to have, but it's expensive.
Yeah, I don't know what John's solution is. Yeah, I haven't seen it. Look forward to seeing the presentation.
He's got 15
Well, so the
When you're presenting, are you next?
no,
Oh.
but in that particular case, what I've done is taken an abstract model that can be built on top of type oracle, reflection, or Java X-Ling model.
Okay.
So you can actually run it from APT.
with a subset of the functionality
No,
provided by each.
right.
Yeah.
I mean, the one complication is when you're doing from reflection, you don't get the parameter names of interfaces.
Yeah. Is it 1.7 that we get that?
I'm not sure.
It's coming.
That would be a pretty big regression. I know Sencha has its X template thing. It also uses that. And as far as like developer interface, it's very nice to be able to have the parameter of the method be referenced in the template itself.
Well, and it's critical for ITN because you wind up putting that in translated instructions as well.
I mean, you could get around it by requiring like verbose Java annotations on every parameter, like at param name.
That's too much work, but
yeah.
in that case, you just fire up JDT and there's a snippet parser. It's really lightweight parsing of the Java, and then you can get the parameter names.
Yeah, that was actually one of the things we were discussing before. Is like, would it be possible actually to just rely on regular old Java reflection unless you detect an actual call to get the parameter name, and if it only in those cases for those classes that you actually fire up JDT to get the parameter name. Otherwise, you just use regular Java reflection for everything else. Like, could you short circuit? So if you're loading like 1,000 files, you don't have to run JDT on all of them. You only have to run it on ones where the generator's actually asking for the ground name. I don't know if that actually would lead to a performance increase, though.
Okay.
We'll see. Are we done, though?
Yeah.
Any other questions? Anybody? Okay, thank you. So I think the next talk is about MGWT, and then there's actually a breakout session. I think Colin is going to lead that about Selenium and browser testing, starting at 3. So that's going to be from 3 to 3:45. This sign-ups were about 4. I think that's in the next room. Let's see. And Mary has volunteered to do a short tour at 3:45 to the beehives. So we have these bees which we have are there. So anybody wants to go take a look.
No one's allergic to bees, I hope.
You're unlikely to get bitten, but you never know.
I'm not worried about getting bitten. I'm more worried about getting stung.
Will bees actually even have mandibles like white? They just have like a, what's that thing?
That's because if you look like a flower.
I think they just have a straw, right? Like there's some bugs that only have like a straw that they get stuck. Like ants bite, they have like a pinch.
Oh, and there's snacks there. So,
Kaikki hämmästyttää se, että hadronien terveysalan puolelle kuuluu
He's wondering.
Yeah. I knew you were going to talk to me, so I just get further question.
So normally what I do is mostly
No yksi mitä muuta kuin se tekemään. Sulla on tavallaan tämä asia, että
I was just curious.
on näköjään.
Oh yeah, of course.
Teema kai viitit pistää edellisen moduulin, koska siellä ei ole mitään oikeasti sitä. Se ei tee mitään se viikossa.
Said it didn't you once, and you said it somewhere else.
Mitä voisi tuottaa? Mitä paljon voi tuottaa?
So trying to
Just for 15 minutes? Niin, mä kirjoitan kaikki client koodit.
I know nothing about that stuff.
Tu fais ta main, c'est bon? Non, mais on a trouvé social media. J'espère que c'était permis par moi, je prendrais le temps de faire d'abord la main. On se retrouve la première fois qu'il fait une publication publique qui n'est pas privée.
If you run it only on the computer set of methods I use here, you don't get a little degree
I like how you run code generation.
but that's what the second module. You compile.
Give me the presentation.
everything should be like so I was expecting to get more games, but it seems like
Once it's compiled,
I would
custom.
So separate from Pestle, I've got this. I wrote a more so like database, you know, where you have to get a set and I ran into the same problem. Like, well, so I made an employee with a given set so what I ended up doing was
number of classes, and you preserve one.
So like what the code generator generates at the base.
All the subclasses.
So just replace the touchdown stuff.
They're all between the class ID and maximum child. So you this is a question. You just have per question you just have
whether after you finish building a tree, then you go back and
yeah, I do it. I do this type for things like and you can reload when you create a type work, then when you reload it, it's serialized.
But after something gets pruned, you never have to change the ranges. They'll never. You won't make them smaller. You don't want to do it every time to the loop.
No, and the code everything else. No, it's only construction element.
I want to do something with
and you only get 6 seconds back after the that impressive.
The thing about the thing is, there's a lot of
yeah, but
it's the same thing I was talking about like closure optimizations, right? Like if I like there are times where like I said like they maybe save those like 0.1% code space, right? And basically like it's not enough to justify like but if you look at the closure optimizations it's like 50, 60. Well now you're talking about numbers. 15 times now you're up to like 5% code save. So like each and every little bit helps as long as you generate lots of those little like 15-second things.
yeah, but I think Edward I think especially if they were trying to target mobile.
Yeah, and they're starting to actually talk about that. And basically, their only solution right now is actually physically break up their applications. And not code splitting, but actually like write smaller apps.
As you said, they do.
Yeah, but they're trying to break up CM into smaller pieces now. But like average, all total is like 10. If you add up all the fragments, it's like 10 megabytes of Java.
Yeah, those are all different
But I think there's the way Edward is developed compared to Wave, it was a lot more enterprisey that was writing it, and so I think that's where it's a really huge. I know.